hosted nodes, and other development infrastructure that is necessary to easily develop applications for distributed systems and blockchain networks. And several teams have started using this developer platform to build all sorts of tools in the ecosystem, like block explorers, wallet. These are just a couple of examples. There's so much awesome work that's being done in the ecosystem every day. And in particular, I'd like to highlight one team that we work with very closely. Textile is a team that's been in the IPFS and Filecoin ecosystems for a long time, and more recently has been building out a suite of tools to make development on Filecoin seamless and intuitive. Textile's PowerGate is an easy-to-use interface to store and retrieve data on the Filecoin network, and it also exposes a really intuitive developer API. We're also building a Filecoin GUI that will enable a broader set of users to engage with Filecoin using familiar user interfaces. We're hoping to enable kind of a Dropbox or Google Drive style storage experience. We've learned that Web3 products and services can be intimidating to users that are new to the space, and this is our attempt to lower that barrier to entry and inspire delight in some of our early Filecoin users. So all of these products and many more are going to be live either very shortly or within the next few months. And while the Filecoin ecosystem is vibrant and growing, this is just the beginning. The space is so wide open, and there are just countless opportunities for developers who are mission aligned and want to start building now. This is what I would like to focus the remainder of my talk on. What are some of the most compelling opportunities that we believe need to be addressed in the short to medium term? First is this idea of storing and distributing Web3 user data. Storing Web3 user data on the Filecoin decentralized network allows users to have the assurance that their data isn't in the control of large centralized institutions. Filecoin storage is actually specifically tailored to meet the needs of Web3 applications that are aligned with the values of user data control and decentralization. And you can already start integrating Filecoin storage into your Web3 applications today. Another opportunity is this idea of data marketplaces. Many of us already work in the Web3 space, so we don't need to be convinced about the importance of data privacy, but we might need to be a little bit more convinced about its urgency. I personally used to do bioengineering research in brain-computer interfaces a few years ago. We're not so far away from a future in which some of our most personal data, our neural impulses, will be captured and stored by digital devices. In that future, having robust solutions for users to take control of their data, but also to benefit from the insights from data analysis will be very important. Filecoin could be this decentralized, efficient, and robust storage layer for personal data vaults. And individuals like you and me could rest assured that our data was actually fully in our control. And while this feels especially urgent when you think of kind of the long-term future of really sensitive data like neural impulses, this sort of system would have enormous value even today for all sorts of personal storage of files, videos, photos, and more. There's still loads of research that will be needed in order to produce these types of robust data marketplaces, including homomorphic encryption, scalable smart contract platforms, and data verification protocols. But we believe this is a really exciting field and space. And the good news is that the decentralized storage side of this problem already has a solution today. Let's look at another example. We've seen a need for applications that focus on data authenticity and are geared towards users who see significant value in time-stamped verified storage. I touched on this at the beginning with the example of our work with the Shoah Foundation. This project relied on having time-stamped public records of data that was being stored on a blockchain. It also relied on data being content addressed or identified by a unique fingerprint that's generated on the basis of the actual data, as opposed to where the data is located. These content identifiers were used as checksums to gain confidence that the data that was stored hadn't been tampered with over time. In some of our interviews with users, we found that this use case actually resonates with a number of groups: lawyers looking to validate documents, universities looking to validate formal transcripts and other media, and more. So developing applications to expose verified storage functionality to a broad set of users has the potential to be immediately relevant in a number of fields. I have a few more. I'll quickly go through a couple of other examples. Filecoin is actually ripe to start enabling smart contract interactions over large data sets stored on the Filecoin network. As I mentioned before, some of these bridges to smart contract platforms will still need to be built. Some are already in progress, but those that aren't are really excellent opportunities for developers to jump in and start connecting these different ecosystems. Because Filecoin storage nodes are geographically distributed, Filecoin can work as a video distribution platform and a CDN to provide videos to end users more quickly. You can also use Filecoin to store virtual world assets. So this is either for game publishers or user-generated virtual assets directly. And Filecoin can also be used to distribute games, packages, containers, and a lot more. There's so much more that I could say about what we've been up to on Filecoin or other ideas for you to chew on and explore. But I'd like to close with a reminder that what we're all doing as part of the Web3 space is extremely important, and also that this is just the very beginning. Filecoin is launching mainnet in a few months, and there are boundless opportunities in the Filecoin ecosystem. And awesome. So I think we might have a few minutes. If there are any questions, I'm not sure how this works, but happy to take questions as well. Yes, I will upload the slides and send them. I don't know if the event organizers can send them out. I think there's a question here about what are the minimum requirements for a Filecoin node. So this is a good question. In terms of being a client on the network, so just using, just storing data on the Filecoin network, there are no minimum requirements really. So anyone can store their data on the Filecoin network. In terms of being a storage miner on the Filecoin network, because of some of our product requirements, we wanted to make sure that the chain would be really scalable and actually able to accommodate the exabytes of mining capacity that we've seen, mining interest that we've seen. So the minimum requirements right now for being a Filecoin miner they're currently being defined, but it's something like a couple hundred. I think it's 100 terabytes for a Filecoin storage miner is the minimum requirement currently, and there are a couple of other requirements. These are all published on our documentation site. What's it like to work with Juan Bennett? Juan is super awesome, really inspiring. It's been an amazing journey working with Juan over the last few years, for sure. How does the data verification process work with Filecoin? This is a great question. It's a little bit complicated. So I would maybe direct you to some of our great explainers that are on docs.filecoin.io, where we describe some of the storage verification process in a bit more detail. Is Filecoin hiring and or looking for open source contributors? Yes, absolutely. I can maybe include a link to where our job description is, but Filecoin is supported by Protocol Labs. So Protocol Labs has a number of job opportunities for people to work full-time on the Filecoin project, and we're always looking for open source contributions. We have a Filecoin community space on Slack. If you go to our website, you can see a number of resources for community members for like where to participate in the Filecoin conversation and what are interesting development opportunities and so on. see, how is privacy addressed? So so just like with IPFS, privacy is addressed on the client side. If you, as a user, want to make sure that your data is encrypted, you would do that while you still have the data, and then you would transfer it to storage miners. I guess that's one element of privacy. There are a number of other elements. If there's more detail on this question, I can dive into that a little bit better, or a little deeper. For projects looking to use Filecoin for storage, do you recommend to first build with IPFS? Not necessarily. So, IPFS is it depends on what the use case is that you're looking for. IPFS and Filecoin can be used together or separately, depending on whatever the use is, but not necessarily. But I think IPFS is an incredible ecosystem and has a lot of really great documentation as well. So if you want to see what is maybe more immediately relevant for your use case, you can look there. So Cameron asks, what are PL's long-term plans for computation over the data? Would that be a different layer on the Filecoin network or a separate network? This is a great question. There are a couple of things, already today, like I said, we're starting to investigate and build bridges with existing smart contract platforms that would enable computation over data that's stored on the Filecoin network. This is, I guess you would think of this as, a bridge or a separate layer. Longer term, we do have plans for some sort of computation support in the Filecoin network as well. This is described in our initial white paper, so you can read a little bit more about some of the future plans there. Okay. And then I think maybe I'll just take this last one. Filecoin will launch with some kind of marketing. We're doing a number of things to get ready for launch. We're starting to work with more community members. We have a new Filecoin website. There will be a lot of energy that we're going to put into the launch for sure. And so we're really, really excited about that moment. And I think I will, with that, sign off. If folks have any questions, I'm always available on Twitter, and I will upload my slides online and send them to the event organizers to share as well. Thank you so much.
Awesome. Thank you, Pooja. Well, that was absolutely fantastic. Really glad to understand that roadmap, and definitely great stuff coming out of Protocol Lab. So up next, we have building the blockchain agnostic Oracle network for the future. Leading that is going to be Sergey from Chainlink, co-founder of Chainlink. And so Chainlink is building a blockchain agnostic Oracle network to connect any off-chain system to various blockchains, connecting them to the real world. The vision that has taken shape in numerous blockchains will integrate Chainlink as their preferred Oracle network to enable their developers to easily build connected dApps. Really, really excited to bring Sergey on. And, who else is excited for Sergey? All right. Are you with me, Sergey?
Yeah.
All right. So it looks like your video is, I hear you, but I don't see it. Oh, there he is. Awesome. Well, I'll leave you to it. Cheers, man.
Great. Thank you, Dustin. Hi, everyone. I guess I can't see you in this wonderful new world we're living in, but I guess you can hear me. Let me just make sure I share my screen, and then we can get started.
There you go. There it is. And you just got to share your whole screen in order to do that. So make sure you have a desktop with nothing that is sensitive, obviously.
Okay, do you guys see the presentation now?
Yep.
Do you see anything?
Yep, there you go.
Do you see anything other than the presentation?
No, the presentation's it. And then go ahead and turn your video back on, and you're good to go.
Okay. Give me a second here to make sure. Sorry for the delay here. Okay, is that it? Can you see my shared screen? All right, I'm going to assume yes unless anybody tells me otherwise. So, hi everyone. Thanks for joining me here in the new world where we all talk to each other remotely and never talk to other people in person. Hopefully not for much longer, but glad to chat with you about all this in this new format. So I think what we're going to be talking about, again, to nobody's surprise, is going to be oracles and how they fit into the larger vision of smart contracts. I think the first useful thing we should get on the same page about is the necessity of smart contracts being able to connect to real world events. So the core of the limitation here that isn't super well known yet to enough people and is slowly getting more well known as more applications get built that actually use smart contracts in this more advanced manner is that you can't actually have a smart contract connect on its own to real world data. If a smart contract can't connect to real world data, like shipping information, weather information, market information, you can't build a contract around that information. This is known as the Oracle problem. It's a significant problem in the evolution of smart contracts. That's kind of a side effect of the security dynamics that secure the transactions within the blocks of a blockchain itself. It's a dynamic that's generated by the security assumptions of those systems, and it's something that's greatly limiting what smart contracts can be used for. It's actually the predominant reason why our space is so defined by tokens. Our space, in my opinion, is highly defined by tokens because that's what people can build. If all that people can build out of the box is tokens, then they'll build a lot of tokens. There'll be a lot of documentation about tokens. People will build a lot of things to do other things with tokens, such as move them around and exchange them, which is all very good, and that's great. But that isn't the long-term promise of this technology, in my opinion. It's not. A lot of the other events-driven contracts that define the $600 trillion derivatives industry, the insurance industry, the lending industry, all these large global, extremely important industries are only being slightly encapsulated within smart contracts, partly due to the technical limitations we're going to discuss in a minute, and then we'll discuss how we would go about solving those limitations. So the outcome that we're trying to achieve is one where we arrive at both a huge amount of growth in what smart contracts do and an overall increase on a percentage basis of what smart contracts are responsible for. So right now, smart contracts are responsible predominantly for generating tokens, maybe attributing that token's value to some other asset somewhere, and exchanging tokens. We want to expand that definition to include all the other events that define the insurance industry, the financial industry, global shipping, and if that happens, two important things happen. The larger space basically grows. The entire blockchain industry grows probably to a massive degree because those contracts have massive amounts of value, in many cases more than the definition of ownership. And the other thing that happens is smart contracts become redefined from a tool for making tokens to a more multi-purpose tool that hopefully comes to define all digital agreement, which in my opinion is what I got into this industry for and what excited me about what this technology can do to begin with. Now, I think that the way to examine this properly is what is the historical evolution of a technology like smart contracts, and how can that be considered in the scope of this large growth and this switch from tokenization to tokenization plus all these other types of contracts. I've seen our space go through 2 iterations already, 2 redefinitions of what the space is about. Initially, when I joined the blockchain industry, it was about Bitcoins only. It was about something called programmable money, where you could basically do multi-sig, or people could sign things and send things on to other people, and you could put a very limited amount of conditions, basically in regards to a Bitcoin, or some fork of Bitcoin that had a different name. Then you would arrive at something what I call protocol smart contracts, or FAT protocols, or whatever we want to call it. It's these really big protocols where you can't actually write a contract as a user. You just have contracts or different contract types built into the protocol. That was very, very limiting, and it didn't allow people to generate lots of new contracts. It required a lot of interaction with protocol developers, which took months, sometimes over a year, until you got something out on production, and it was a very onerous process. So we basically saw a transition to scriptable smart contracts, for which Ethereum deserves the vast majority of the credit, is that they pioneered this approach of let's create these contracts. We can script up all the conditions we want to script up. The one limitation is that the primary thing that people can script up is either tokens or voting. So they can either generate tokens or they can generate votes, commonly in regards to tokens, deciding how much they can vote or voting on something related to a token. So that was a huge innovation and a huge leap forward, and it generated that huge leap where you saw these people generating tokens and all the exchange infrastructure that came about from that, and so on. So that was a huge leap forward. In our opinion, the next leap forward is the ability for scriptable contracts to now be used in the context of all these real-world systems. So all the systems that provide you with high-quality data, high-quality payments, all of these kind of high-quality capabilities for defining a derivative or defining an insurance product or defining a trade finance product, or even taking those products and turning them into something that becomes a token, that's fine as well. But you basically can go to a much higher level, which is the level that the rest of the digital world is on. The digital world is not on the level of I can generate a token, that's all I can do. The world of digital agreements is on the level of I can write digital derivatives. I can write digital insurance products. They call them parametric insurance. I can write digital trade finance contracts in certain forms with electronic bills of lading and other features. And if we want our space to be defined by something more than tokens, we have to seriously think about how do we create an environment and a set of capabilities where developers can build all of these contracts such that they could not only compete but greatly surpass all of these other digital agreements, which genuinely have big failings that smart contracts successfully overcome, as long as they reach feature parity in terms of all these other capabilities which digital agreements have, which is kind of the body of work that we're really engaged in. Now, I think we've already started to see this, and this is kind of what DeFi is. DeFi is a rapid growth, if albeit in absolute terms, it's not a very large dollar value growth when you look at the types of products we're talking about. So it is a very large growth where you see DeFi suddenly going up and to the right, partly because people have tokens, once again, so it's a good thing that tokens exist. They have tokens to use within a DeFi context, and there's enough people with private keys such they could put those tokens within a decentralized financial product, and that allows that to exist. So it's a very logical and useful progression from tokens to these more advanced contracts. But if you actually look at these decentralized financial products, you'll see that they're made by companies like Synthetics, Aave, BZX, Nexus Mutual, and others, many of which are our users and many of which basically depend on oracles. And if you look at the actual real-world application of smart contracts to something other than tokens in the case of DeFi, you'll see that contracts are built in a very simple, repeatable pattern that doesn't really deviate. The pattern is that you now have contracts made up of 2 parts. You have an on-chain part and an off-chain part. The on-chain part is where contract conditions are expressed, and the off-chain part is where interactions with both payment systems, enterprise systems, data sources all have to occur. Now, as we said before, because of the Oracle problem, the on-chain part can't fulfill those conditions. It can't access all of those systems. And the few people that have tried to to implement that into a blockchain have encountered large failures, security risks, and there's a number of security problems that come with increasing the input output and the network IO and all the other kind of capabilities, and also the effects it has on consensus. So this is essentially what a DeFi contract will look like, as well as decentralized insurance, as well as other contracts, such that you're expanding the capabilities. And in expanding the capabilities, you're creating more surface area. So where your surface area before was just the contracts in the middle, now your surface area is the contract in the middle, which is secured based on audits, based on the properties of the smart contract language you use, based on how you write the contract. But now you have another surface area, that second half of surface area, which is all these other systems that your contract has to interact with. It has to get market data to create a derivative. It has to get certain data to make an insurance product about weather and rainfall. It has to sometimes interact with other systems in an enterprise context to update an enterprise system or send a payment. So you've expanded your capabilities, which is really great and exciting. You've also expanded attack surface area, which you need to secure. And this is essentially the body of work that we're involved in. So we want people to be able to have a huge amount of contract inputs. We want them to have a huge amount of contract outputs. We want them to have that capability on all the blockchain environments where they want to write those contracts. And we've already integrated with numerous environments, both on the enterprise side and in the private chain world and on the public chain side. And we're launching more every 3 weeks at this point, and we're in integrations, I think, with I think double digits amounts of blockchains at this point, making sure that they get access to these capabilities. Now that's really the body of work that we've undertaken. We don't make a smart contract language or a blockchain ourselves. We don't make any of the decentralized financial products that could possibly compete with our customers and could stop people from wanting to use our oracles. We don't have a dilution of our focus in any of these respects. We simply focus on creating a highly secure oracle mechanism, about that oracle mechanism generating high quality inputs into all the environments that people want to interact with those inputs, in this case blockchains. Then those blockchains often need to go out and make outputs. Those outputs take the form of commands to enterprise systems, they take the form of commands to traditional payment systems, and they take the form of commands even to crypto payment systems if a certain type of token or cryptocurrency isn't available on the blockchain where the contract lives. And so this is the body of work that we've undertaken, is creating an environment in the blockchain world, in the blockchain kind of industry, that is basically data rich and feature rich. So that users in the sense of contract developers can show up and click together all the different capabilities that they want from various data sources of various quality at various price points, and to have their contracts generate various outputs, whether that's into an enterprise backend they've already built, or whether it's into a payment system their customer wants to receive payment in, or even another blockchain's cryptocurrency payment capabilities. So the goal of all this is really arriving at a world where smart contract developers can build applications the way web developers do. Web developers in a week or two can build an MVP, a minimal viable product version of things. And that really starts to allow them to not only add more features, but launch at all. And we've already seen a number of users both launch with us, secure now tens of millions of dollars in value as a result of quickly being able to launch using an oracle mechanism that they didn't need to build, focus their kind of constrained technical resources on the building of a good financial product, and therefore make that more financial product successful faster, more useful, more capable in terms of the features it has, and that contributes to that growth in DeFi. So I'm quickly going to run through our reasoning and approach to this. Hopefully I'll have time to get through most of it. The first tenet that we undertake is decentralization. It's the fact that these Oracle networks right now, they don't run at a size of less than 7 nodes, and many of them are beyond 20 nodes, soon to be approaching 30, and then beyond with various scalability improvements, such as threshold signatures, which should be coming out in the relative near term. We also focus very heavily on the security of nodes, so we have lots of proof that a node is of a high quality. rather than just assuming that dynamic membership will give us a large multitude of nodes, which will then create inefficiencies that it could be hard to step away from if we want to make user fees responsible for paying for the infrastructure, rather than subsidizing a huge amount of pseudonymous nodes from dynamic membership. So we focus on a model of decentralization plus extremely high quality nodes. So we try to balance quantity and quality, rather than just saying we don't care about quality of nodes, we just care about massive quantity, partly because that has efficiency issues and it creates very large costs that, at least in the context of making an Oracle network, would be hard to overcome. For example, the many Oracle nodes, if you had thousands of them and they were all low quality, they would still need to pull data from hopefully high quality data providers. And if they're not pulling data from high quality data providers, you arrive in a situation where, garbage in, garbage out. Bad data in, doesn't really matter how high quality the Oracle mechanism, you're going to have serious issues. Well, depending on the nature of the product and how much value it secures, but eventually you want to arrive at high quality data. That's the next problem that we've seriously undertaken, is assuring to a smart contract that its data is of high quality, such that not only is the developer assured of that, but the user of the smart contract is assured. This assurance about both the security of the data and how it's transported, and the quality of the data being sufficiently validated and scored and at a high level of quality, is something that should give people assurance about the end-to-end security of a contract, such that they can then put more and more value into it, and we can go from DeFi being about between $500 and $1 billion to trillions of dollars, just like the derivatives industry is worth trillions of dollars, right? It's completely conceivable that the derivatives industry, insurance industry, global lending industries eventually end up on blockchains, and what they really need is they need a capacity to do that in a secure and high quality manner. Part of that is data quality, because large amounts of value will probably not be triggered by free APIs or APIs without passwords or any other weird collection of ideas that seem to ignore the fact that data quality is quite important when you have money attached to the quality of that data. We also focus on crypto economic security in our approach, where we seek to basically provide penalties through very clearly defined terms of performance. So the user contract forms a service agreement with a Oracle contract, to which the Oracle contract commits. Once it commits, it then generates various parameters under which it would lose stake. Losing the stake is essentially a loss of a deposit. It's a penalty, an economic penalty that motivates the data provider and the node operator. In many cases, they're one person to do a good job and deliver data on time at a high quality and at a high level of security. We practice something called defense in depth of security, such as trusted execution environments, zero knowledge proofs, and all those things are on a roadmap to be released to once again increase the amount of security, which should once again give people assurances that they can put high amounts of value into a system that's triggered in such a manner. We do this together with a large open source community that's growing by the day, and for which me and our entire team are very grateful for, and very grateful to all the people in that community that take the effort and the time to work and think on this problem together with us. We don't spend enough time publicly talking about how much we appreciate it, but we really, really do appreciate it. And it is having a very large impact on how we're able to get people to benefit from this technology. So I don't have many opportunities to say this because I'm not very public, but I really do appreciate it, and thank you. We also seek to do this and are doing this successfully now for many, many different blockchain environments. We have a framework for onboarding new blockchains that's pretty efficient, and we're able to do that at a high level of security, efficiency, and replication of the existing data feeds that are on one blockchain. They can now be replicated onto these other environments, so that if a developer shows up in any blockchain environment, he can now make a DeFi product without having to spend months building some kind of Oracle mechanism and figuring out data quality. The first problem we sought to solve with this collection of kind of principles and tenets was centralized oracles. Centralized oracles are largely now considered a faulty way to approach an Oracle mechanism. They don't provide security. It's not something I think we need to spend a lot of time on, but the idea of having a centralized Oracle validating an input into decentralized infrastructure basically says I'm comfortable with a failure point in a system that has control over my contract, but I'm not comfortable with that same failure point in the contract itself. which isn't a very logical statement in most cases. So even in an enterprise context, as people begin to consider a lot of the security dynamics, as they begin to see the security benefits and the efficiency gains from smart contracts, they begin to also move towards decentralization, because decentralization and security guarantees and transparency guarantees once again come from decentralization. They don't come from a single point of failure having unilateral control over a contract that should have many other more exciting properties like tamper-proofness, transparency, immutability, and so on. The first tenet is once again decentralization, where we generate a multitude of oracles, and those oracles validate inputs in the similar way that miners mine blocks. They validate the quality of those inputs under a set of very clear parameters. You can select nodes on the basis of their quality metrics, and in this case, this node has four verifications about its quality. It's been verified by something called Keybase for identity. It's been security verified by our team. It's been verified by the marketplace that it's listed on here, and those amounts of verifications will increase. You can see the total runs. You can see the adapters. You can see the feeds that it's participating in. So the point of our system is to generate massive amounts of data so people can make informed decisions about the quality of a node, and therefore compose a group of high-quality nodes into an Oracle network that gives them those guarantees at both the level of guarantees they want and at the cost that they're willing to pay for those guarantees. The second part of our approach is binding service agreements, which is quite important because those binding service agreements generate a commitment on-chain. That on-chain commitment requires the Oracle to guarantee the outcome, and that guarantee of an outcome generates both an kind of unequivocal, difficult to misunderstand, almost impossible to get away from commitment about what that Oracle is going to do. And then together with staking, you basically arrive at a place where the commitment is now also backed by a deposit. And so the commitment is forced to be very clear. We basically force our oracles to make extremely clear guarantees to user contracts. And those extremely clear guarantees are then insured by staking. And that staking correlates with the amount of fees people should pay. So you get many security guarantees. You get decentralization, you get high quality nodes, you get crypto economic guarantees, and then you're able to define the costs of that as a node operator to a user, and the user can then decide how much they pay for what degree of guarantees. And sometimes nodes might have to have more stakes, sometimes they might have to provide other guarantees. But as they provide guarantees, what you end up seeing is a very large amount of users start to use high quality nodes. This creates a large web of trust dynamic where all the usage of those nodes by users basically provides greater and greater amounts of cryptographically proven performance. And that proven performance is then once again used for people to decide on what nodes they want to use, and eventually you arrive at a place where you have very strong security guarantees about the quality of a node, their economic incentives, and the security of their system. Now, once you decentralize the middleware level, you arrive at a place where you can decentralize the data level. Now, decentralizing the data level is not as simple as people seem to think. You for example, do not want to use free APIs. You don't want to use uncredentialed APIs because it just doesn't make sense that you trigger millions of dollars using some free trial or unpassword, non-premium API. Nobody in the financial world would ever sign up for that we're going to use the trial plan or the free open API of some system that has no economic incentive to maintain the quality of the API, gives us no guarantees about the quality of the data. And so decentralizing the data level comes after decentralizing the middleware level. But once you decentralize on the level of data providers, which we also heavily focus on, you then actually need to arrive at a place where you're starting to score data providers as well as node operators, and you need to think much more deeply than I've unfortunately seen some people do about how does the data that you're telling people to rely on in your kind of Oracle system, how does that data get generated? How is it sourced? Does it provide market coverage of all the places where price discovery could happen, or does it miss exchanges where all of a sudden price discovery could start happening and you could have a huge arbitrage that basically breaks a decentralized financial product? there's a number of these issues which I'll be glad to go into at some later point in future presentations. I don't think we have time now, but the approach that we've always had to this is one of flexibility, as many of the things that you see in Chainlink. So the approach is really that we have certain nodes that are run by data providers, and really from day one we've been having data providers that source data from cryptocurrency exchanges by providing market coverage, aggregate that data in a logical manner to make sure that no new exchange or no new source of price discovery escapes them. And then those data providers themselves have been, I think, some of them for maybe years now. I mean, they've been running these nodes. And when you run a Chainlink node, you out of the box get transaction signing. So you out of the box get the ability for a data provider to sign messages as long as they run that Chainlink node within their infrastructure. And that data provider then gets the capability to sign those messages into all of these hundreds of blockchains which we're going to be integrating, right? So the benefit from the data provider's point of view is quite large in that they don't need to build or rebuild whatever system they have. They just ship APIs the way they've been making APIs, and then they run a piece of software that essentially has its own segregated properties and security dynamics and its own separation of concerns, and focus on allowing them to broadcast that data or to create interactions between their existing API and the hundreds of blockchains that exist now, all the blockchains that will come to exist, all the variations of those blockchains in public and private form. And so we already have data providers that do this, and they've been doing it successfully. And I think they're the data providers that are going to see themselves be able to put more data on various chains much faster, because they won't have to reason about changing anything or kind of doing any infrastructure changes. So we already for years now have had data providers running their own Chainlink nodes, which out of the box gives them very secure signing capabilities. And they've been doing that together with node operators that are just professional node operators, like Certus One and Chainlayer and Chorus One, Stakefish, extremely high quality node operator teams that pull data from data providers that are not ready to do that. There's a multitude of data providers that don't have the bandwidth, don't have the technical resources to build some kind of system for blockchains. They don't even have the technical resources to run a separate piece of software to sell the blockchains. But they do have data, and if you consume that data in the format they provide it, then they will provide it, and then the users on these chains will have it. And if they will have it, then we will see DeFi applications grow in the way that we want to see them grow, and our space become redefined in the way that we would like to see it redefined. But we can't, in some hard-nosed manner, say, well, the only way that you can contribute to the blockchain ecosystem's growth is if you take this onerous path of changing how your systems work completely, you turn them upside down, remake every single API, or why don't you just, I'm going to force you to run some software which you don't know why you should run because the blockchain market isn't big enough for you as a data provider yet, which is this chicken and egg problem that's very easy to ignore, but we ignore it at our peril. And what we should really do is we should make a flexible system that allows the data providers that want to be more involved to become involved very easily and sell their data to a very large market. And the data providers that have high quality data but do not yet see the purpose of being super involved, for them to have a piece of software that they can run and that can provide security guarantees which we can rely on while also providing high quality data into these environments. And this is the flexible kind of approach that will provide the largest amount of data and therefore make the blockchain world the most data rich environment it can be, because it's impossible for us to predict what people will build. All that we can really do is provide the largest amount of inputs that we can. And that's what our system is focused on, together with extreme levels of security guarantees. All of this is something people can see today on feeds.chain.link. We have many feeds going live. So if you're a developer, we would love to help you build a great DeFi product. And all of what I described, or at least the most of it is live now with multiple data providers running their own nodes, and data providers that don't want to run their own node but do have high quality data also feeding their data into these feeds. We're very excited to help people build great DeFi products, and we work very closely with the teams we work on these problems with, and if there's anything we can help with, I hope you as a smart contract developer on any of these environments will feel free to contact us. Now, that's at the end of our goal. It's at the end of the day, our goal is to provide all of these inputs and outputs to these developers, regardless of the environment they're on. Our goal, fundamentally speaking, is to bring DeFi, decentralized insurance, trade finance, to its full potential by enabling all the teams that want to build these contracts to be able to build them. Another quick example that I'm fond of, and that hopefully we'll be able to see something on production for soon, is the ability to make an insurance contract. And let's say you made an insurance contract for crop insurance, which is actually one of the first uses of many of these financial products. It's not speculation. It's the ability for people to hedge risk in a meaningful way when they do something as critical as providing food to the rest of society. And let's say you generated that contract. You would want multiple sources of data. You would want assurance about the quality of the data. You want assurance about the transfer of the data into your contract. And then you would possibly want the ability to trigger enterprise systems, trigger payments to various groups. Some would want traditional payments in a local currency. Some might want crypto, depending on what their preferences are. And you should be able to make this contract not in a matter of months. You should be able to make it like a web developer makes it in a week or two. You should be able to click in all the resources you need. You should be able to generate all the outputs you need. And that's the point at which we think we'll see this real shift and large improvement in what our space is defined by. That it'll be defined by products that help people in countries where they can't have a contract that minimizes their risk as a farmer suddenly have a contract that's not a contract based on a legal system, but a contract based on a technically enforced set of guarantees, which gives them the ability to manage risk, which is really what a lot of these contracts do for people, and they do it in many very meaningful ways that aren't yet available and should be available to many different people, as well as all these other contracts. So if this is something that you're interested in and it sounds like a worthwhile endeavor, we work on this basically day and night. We're all inside anyway, so it's a great time to work on this. If you have any questions, feel free to contact us. But if this seems like a worthwhile problem, we work with some of the world's best academics. We have a very experienced senior development team that's growing rapidly with more and more very astute experts in cryptography, secure systems, distributed systems. And we're very excited to work with smart, motivated people that see the value of this problem and also want to see this significant change in how our industry is defined and what it can do for the rest of the world.
Awesome, Sergey. What you're doing is awesome work, and really appreciate that. If you want, we got a session going for you already in the sessions tab. If you want to hop into that, I'm sure a lot of people have a lot of questions and answers, a Q&A session that you'd be willing to give, and it'd be really awesome if you could hop over there. And
where is that? I don't know where that is.
I'll just post the link for you here backstage. Just go ahead and
just so you know, I do have a meeting set up soon after this, so
okay.
I'll have to be brief if we do it. So if I can get there relatively quickly.
Yeah, if you just want to just click the sessions tab on the left, and then you should be able to find Q&A at the bottom of the session.
It asks me if I'm sure I want to leave, and I feel like when I click yes, I'm going to fall into a black hole of confusion about how Hopin works.
Yeah, just hop into the sessions and then scroll to the bottom, and it'll be an open session for you. You'll be good.
Okay, makes sense. I'm going to leave here, and I'm going to try to find that session. Hopefully, I'll be able to. If I don't, I apologize, but I'll do my best to find it. Thank you.
All right. Cheers. All right, and we have a few other sessions going.
To share audio and video, and I will allow you to take over the screen. Madeline, Chris.
Spot here.
Just so everyone knows, Adeline and I were texting that we were very proud of the link marine behavior in the chat. So thank you for being by our no shilling policies. So
I love your jacket. If I knew I was going to be on video, I would have got more of my link you're going on.
Welcome to the party. So it sounds like Sergey is going to join us, but it sounds like he has like just a couple minutes.
Yeah, anyway, he has a lot of stuff going on. I don't think this was in the schedule, so Yeah, but
It was
I'm here to help.
So we figured there were questions and maybe someone would have answers. So I guess we can wait for him to join, and then if not,
yeah, or we can just have a conversation here. I mean, it's awesome conference, by the way. It's
Thank you.
been incredible. I'm super excited. I really liked I tried out the networking session, and I kind of jumped in and got paired with some really cool people.
it is a super fun event. So I'm glad that you guys could make it. Closing out the show too, so kind of a big deal.
I know. Save the best, right? One of the best. There's so many amazing speakers here.
Totally. Well, you guys, this is how it can work. If you follow along in the chat, my Instagram is private, Michael, but thank you very much for that.
You got quite the
You
fan.
can follow me on Twitter, though. We can play there. I'm Asher T. But if you ask your questions in the chat, then Adeline and Sergey, if he can join us, or anybody else on the Chainlink team can jump in here. It looks like Alex is asking if you guys are interested in recruiting any data scientists.
I'm not sure at the moment. All the open roles are posted at careers.chain.link, but there is a button or a place on the bottom if you're not one of those roles that you wanted to submit information to, or share with us some other role that you think we should be considering. Definitely feel free to submit your application.
Well, Chris, share your audio and video if you'd like, and we can bring you in.
Jason's question on SmartCon, yes. Oh gosh, with everything that's going on, we're taking note of everything. We're evaluating these amazing conferences, deciding if we should take it virtual or not. So we are keeping an eye out. I know we're so excited. I mean, it would have been actually like this week or something for our SmartCon, but we'll let you know. Please just follow our social media accounts, and we'll let you know as soon as we know as well.
What's SmartCon?
The Chainlink conference, yeah.
Okay, well, maybe I'll get an invite.
Yeah. Oh, your dearest friend. Yes. We're really sad too. We're so excited. We had an amazing venue and everything, but
Where was it going to be?
it was going to be in Brooklyn.
Oh, nice.
Yeah, it was a really cool, hip location.
Okay.
Maybe, I won't say where, or maybe it was said where already, but if it does happen again, when we can all get together in real life, I think it'll be great.
Yeah. I'd be so curious what the Marines are like in real life. Really? Has it happened before? Hey, Rory.
Hey, how you doing?
So,
You
hey.
guys hear me okay?